In this lesson, we'll be looking at function notation. Now we know a function is like a machine for numbers. You put in a number, the machine does stuff to that number, and the machine then spits out a new number. Often we've come across functions written like this: y equals 2x or y equals x plus 1. So really you're saying you take an input x, you multiply it by 2, and you'll get your output y. Or you take your input x, you add 1 to it, that gives you your output y. But it's also common to use what's called function notation, where you would say something like f of x equals y. You're basically saying there's a function named f in this case that's going to take an input named x and give you an output named y. So basically the f of x, that replaces the y. So instead of y equals 2x, you would say f of x equals 2x. Or instead of y equals x plus 1, f of x equals x plus 1. Essentially, instead of writing y, you write f of x. Now notice, when we wrote f and then bracket x bracket, we say that is f of x. Or you can think of it as f at x. What does the function equal at a value of x? It does not mean f multiplied by x. That is not what it means. It's either you say f of x or f at x. This will become clearer as we look through some examples. For example 1 here, we have a function named f that's going to take an input x, and that equals 3x minus 6. You also have a function named g that's also going to take in an x, and that equals negative 2x plus 5. And we're asked to determine the function named f's value when x equals 3, and then the function named g, what's its value when x equals 4. Okay, so basically you have the function you're given, f of x equals 3x minus 6. And you're asked, what is the value of that function when x equals 3? So all you have to do is, every time you see x, substitute 3 in there. So we have 3 times x, but your x is valued at 3 minus 6. So let's evaluate this. 3 times 3 is 9. 9 minus 6 is 3. So your function f, when x equals 3, equals 3. For g at 4, the function g equals negative 2x plus 5. If you want to find the value of that function when x is 4, you'd say, what is the value g when x is 4? So again, all you do is you substitute the number 4 in every time you see x. So here you have negative 2 times x, which you're saying is 4, plus 5. So let's evaluate that. Negative 2 times 4 is negative 8. Add 5, that's negative 3. So your function g, when your input is 4, gives you an output of negative 3. In the next two examples, we're still dealing with the same functions. F of x equals 3x minus 6, and g of x equals negative 2x plus 5. We're asked now, what is g when x is negative 3, and what is f when x is negative 6? So again, we can just substitute those numbers in for x. So we have g of x equals negative 2x plus 5. But I want g when our x value is -3. So I just substitute that -3 every time I see x, and then evaluate it. So g at -3 equals -2 times -3, that's a +6, plus 5, that equals 11. Now for d, we're dealing with the function f. So we know f of x equals 3x minus 6. We want to figure out what that f is when x is -6. So every time we see x, we'll plug in -6. And let's evaluate. 3 times -6 is -18. And then we have a -6 there. So -18 minus 6 is -24. So the function f, when x is -6, equals -24. Okay, a bit more complicated now, but the same process. We still have those same functions, but now we're saying what happens when the input is -2/3? What happens when the input for g is 4√2? Same process, so we have our f of x, and every time we see the x, we're going to write down the input of -2/3. So we want to figure out what the function is when the input is -2/3. So we have 3 times -2/3. 3 times -2 is -6. -6 divided by 3 is -2. Then we have our -6 there. -2 minus 6 is -8. For g when x is 4√2, we'll start with our function, g of x equals -2x plus 5. We want to figure out what g is when x is 4√2. So we just substitute 4√2 every time we see x. So let's evaluate this now. -2 times 4√2 is -8√2. Can't simplify that any further. Plus 5. And we can't add those two together because this 5 doesn't have a √2 on it, so they're not like terms. That's your final answer there. Okay, last example that's using these two functions. What is your output for f when your input is 2a minus 4? Looks a bit different, but the process is the same. You have your function that takes an input and then takes that input, multiplies it by 3, and subtracts 6 from it. You want to figure out what the value of that function is when your input is 2a minus 4, so we do the same exact thing we've been doing. Every time we see x, we replace it with a 2a minus 4. 3 times 2a minus 4, and then minus 6. Time to evaluate. 3 times 2a is 6a. 3 times -4 is -12. And then we subtract 6 at the end. So here, if we clean it up a bit, add like terms, we have 6a minus 18. And that's our answer. Let's take a look at a few more examples. This one says that if you have a function that takes an input x, multiplies it by 3/2, and then subtracts 6 from it, if your function has a value of 6, what did the input need to be? So here we're saying, what is the input what is your x when you know the output equals 6. Given that f of x equals 3 over 2x minus 6, determine x. Determine the input when f of x equals 6. Determine the input when the output is 6. So here it's saying f of x equals 6. So where you see f of x, put in the 6. And then you have that equaling 3 over 2x minus 6. And then you try to solve that equation. Okay? So that's our starting point. F of x equals 6. So where we see the f of x, we write down 6. Now we solve for the input. Okay, so remember when you solve for equations, you do the reverse of BEDMAS. So what we'll look to do is deal with addition, subtraction first, and then look to deal with division, multiplication, and then brackets, exponents at the end. So for the equation we wrote there, 6 equals 3 over 2x minus 6, we'll have to add 6 to both sides of this equation. What does that accomplish? If we add 6 to both sides, negative 6 plus 6 is just 0, so we basically cancel that. We have 3 over 2x equals 6 plus 6, which is 12. Okay. Next step, we want x by itself. We're solving for x. It's being multiplied by 3 over 2. So we do the opposite, which is divide by 3 over 2, which is also the same as multiplying by 2 over 3. So I can do the multiplication by 2 over 3 if I do that on both sides of the equation. Why do I do this? Notice you'll have a 3 on top and a 3 on the bottom. These cancel out. You have a 2 on top and a 2 on the bottom. 2 divided by 2 is 1. Those cancel out. And you're left with x by itself, which is your goal. So the other side of the equation, you have 12 times 2 divided by 3. 12 times 2 is 24. Divided by 3 is 8. So you have 8 equals x. There you go. So what you're saying is, when the input is 8, your output is going to be 6. And since you have an equation, you can check this. Let's check it. Let's check to see, to make sure that the function, when the input is 8, let's make sure it equals 6. Let's see if that's true. Three times 8 is 24. 24 divided by 2 is 12. And you'll minus 6. And 12 minus 6 is 6. So you checked it, it's correct. When the input is 8, the output is 6. Okay. Given the function h at t, this could be something like, oh, the height of an object at the time t. H of t equals negative 4 over 5t plus 3. Determine the input when the output, h of t, equals 3. So same style as last time. We know that h of t equals 3. So substitute in 3 every time you see h of t. Let's do that. Instead of h of t equals all this, we say 3 equals all of that. Negative 4 over 5t plus 3. And you're trying to determine t. You're trying to solve or isolate for t. Okay, so that's our starting point. We'll have to get rid of this plus 3 first. Get rid of plus 3 by subtracting 3. If you do something on one side, you have to do it on the other side of the equation. So, where do we stand now? On the right side, the 3's go away because plus 3 minus 3 is 0. So you'll have negative 4 over 5t on the right. On the left, you also have 3 minus 3, which is 0. So we have 0 equals negative 4 over 5 times t. Okay, we still want to get to t, So what we can do is multiply by a negative 5/4. Because here you'll have a negative sign multiplied by a negative sign is positive, so those negatives go away. 5 on top divided by 5 on the bottom is 1, that goes away. 4 on top divided by 4 on the bottom is 1, that goes away too. We have to do the same thing on the other side of the equation, where we multiplied by negative 5/4. So multiply by negative 5/4, but 0 multiplied by anything is just 0. So here we have 0 equals t, or t equals 0 would be your answer. So what we're saying is the value of h with an input of 0 equals 3. And again, you can test this out. You don't always have to test it, but it's something that you can use to double check your questions or your answers. But if we tested it, we're testing the input 0. At the input 0, what is our h? Negative 4/5 times 0 plus 3. Negative 4/5 times 0 is 0. Plus 3 is 3. H with an input of 0 equals 3. So that is correct. Here we have a word problem. A group of friends are going to see a movie. It will cost them C dollars for N tickets. The cost can be calculated using the formula C of N equals 15 times N. Determine the input and the output for the equation. Well, the input is in your brackets, so this input is N. Input is the N, and the output is the C, the cost. What is the cost with an input of 5? So what is the cost when there's 5 tickets? What is cost of 5 tickets? So we have C of 5 equals 15 times 5, which is 75. So the cost is $75. If C of N equals 105, what's N? So here we have C of N, we know is 15 times N, but we're saying C of N is 105. So we have 105 equals 15 times N, and now we want to solve for N. We can do that by dividing 15 from both sides, because 15 divided by 15 is 1, it goes away. So 105 divided by 15 is 7. So that means N equals 7. So 7 tickets cost $105. Okay, last example, another word problem. The function f equals 1.8c plus 32. And that function is used to convert a temperature in degrees Celsius to a temperature in degrees Fahrenheit. First, we want to write the function in function notation. Well, we can say the value f, or the Fahrenheit value, given an input Celsius value, equals 1.8 multiplied by that Celsius value plus 32. So that's your function in function notation. For part B, it says determine Fahrenheit degrees when the Celsius is 25. Okay, so f of 25 equals 1.8 times the 25 plus 32. 1.8 times 25 is 45 plus 32. 45 plus 32 is 77. So when it's 25 degrees Celsius, it's equivalent to 77 degrees Fahrenheit. Part C, what's the temperature in Celsius at 100 degrees Fahrenheit? Now your F is 100, and you want to determine what the C value is. So you start with that equation, get rid of the 32 by subtracting it. Whatever you do on one side, you have to do on the other side. So on the right side of the equation, you have 1.8 times C. On the left side of the equation, 100 minus 32 is 68. So you still need to get C by itself. It's being multiplied by 1.8. So you can divide by 1.8. Have to do that on both sides. 1.8 divided by 1.8 is 1. It goes away. So on the right side of the equation, we have C by itself. On the left side, 68 divided by 1.8 is 37.8. So at a temperature of 100 degrees Fahrenheit, that is equivalent to a temperature of 37.8 degrees Celsius.